The portion of the universe that can be observed and studied with telescopes and other instruments is referred to as the observable universe. Light, the primary source of information about the universe, can only travel at a certain speed, so this capability is limited. As a result, we can only observe objects and events that are at a certain distance from us. We cannot directly see objects or events that occurred long ago in the past. The diameter of the observable universe is estimated to be approximately 93 billion light-years, which is much larger than the estimated age of the universe, 13.8 billion years. This discrepancy is because the expansion of the universe has caused objects that were once close together to move away from each other, and light from those objects has required more time to reach us. Although the observable universe as a whole is a vast and fascinating space, there is still a great deal we do not understand about it. However, through the use of telescopes, such as NASA's James Webb Space Telescope, and other scientific instruments, we continue to learn more about the structure, composition, and history of the universe, as well as its various phenomena. Join us as we discover the new structures that the James Webb Space Telescope has just made contact with in the far reaches of the observable universe. Subscribe to our channel if you want to get the latest information about the universe and its surroundings. Be sure to like this video and turn on the notification bell. Now, what lies beyond the observable universe? To reach the far reaches of the observable universe, we would need to develop transportation methods that would allow us to transcend space-time, such as using distortion engines or wormholes. These concepts have long been the subject of debate among scientists, some of whom believe that these are simply impossible or contradict the idea of faster-than-light travel. The feasibility of both possibilities, faster-than-light travel and the use of advanced technology beyond the reach of current human intelligence, is a subject of intense debate. It would require machinery and technological advancements that are currently beyond our capabilities, even if it were theoretically possible. The theory of cosmic inflation posits that the total size of the universe is at least 10 squared cubed times larger than the observable universe. This number is so vast that it is incomprehensible to the human mind, since we cannot see or measure the unobservable part of the universe. What lies beyond its boundaries is beyond our comprehension. However, this does not preclude us from formulating hypotheses based on the data we've gathered from distant galaxies. This is where NASA plays an important role. Numerous significant contributions have been made to our comprehension of the universe by NASA, other space agencies, and research institutions worldwide. Even before the James Webb Space Telescope became operational this year, NASA had already released images of the ultra-deep field, obtained with the Hubble Space Telescope. However, when the James Webb Space Telescope made its debut, it was taken out to observe the most distant galaxy ever recorded. These images revealed the presence of numerous galaxies shining in the distant cosmos, apparently, as they were millions of years after the Big Bang occurred, approximately 13.8 billion years ago. The expansion of the cosmos causes the stretching of light to redder wavelengths, which allows the James Webb Space Telescope to detect infrared light. This has allowed us to observe galaxies forming in the early stages of the universe's history. Scientists can now examine the rate at which stars formed in the early universe, thanks to the James Webb Space Telescope's observations of several fields of distant galaxies. This data reveals the existence of a significant population of galaxies that were forming stars in the early stages of the universe. These discoveries truly intrigue and provoke thought. For a long time, humans have contemplated the possibility that we are not alone in this vast universe. However, these new determinations within the observable universe lead us to believe that there must be millions of galaxies in the unobservable part of the universe. This idea is truly shocking and awakens a sense of awe and wonder about the vastness of the cosmos. Where in the universe are extraterrestrial beings located? The likelihood of life beyond Earth has never been more compelling, leading us to consider the possibility of the existence of extraterrestrials. There are numerous planets outside our solar system, known as exoplanets, which have been discovered using techniques such as the transit method and the radial velocity method. There is a possibility that some of these exoplanets contain life and share characteristics with Earth. This theory has been supported by another discovery made thanks to the James Webb Space Telescope, related to the exoplanet WASP-96b. This planet is outside our solar system, and its light spectrum reveals something surprising: the presence of water molecules. The spectrum also reveals hints of haze and clouds that were not previously thought to exist on a planet that could support life. Based on the habitable environments found elsewhere in the universe, and considering the advances in the search for exoplanets, it is difficult to rule out the possibility that alien beings exist beyond our planet. Although we do not yet have conclusive proof, discoveries and evidence suggest that the existence of extraterrestrial life is a fascinating possibility worth exploring. As our technological capabilities continue to evolve, so too does our ability to detect signs of life beyond Earth. Missions like TESS, Transiting Exoplanet Survey Satellite, Kepler, and now the James Webb Space Telescope have vastly expanded our catalogue of exoplanets. Some of these planets are located in the habitable zone, the region around a star where conditions might be just right for liquid water to exist. Water is a fundamental ingredient for life as we know it. The discovery of water vapor in exoplanet atmospheres raises the exciting possibility that Earth-like conditions could exist elsewhere in the universe. But water alone is not enough. Scientists also look for biosignatures, which are chemical signs that could indicate the presence of life. The James Webb Space Telescope is particularly well equipped to search for such biosignatures. Its powerful infrared capabilities allow it to analyze the atmospheres of distant exoplanets and look for elements such as oxygen, methane, and carbon dioxide, gases that, in certain combinations, could suggest biological activity. Still, even with these advancements, the search for extraterrestrial life remains a monumental challenge. Distances are vast, and the signals we seek are often faint or ambiguous. Yet, the progress made so far fuels our curiosity and inspires further exploration. The discovery of alien life, even in the simplest microbial form, would have profound implications. It would mean that life is not unique to Earth, but a natural consequence of the universe's conditions, a revelation that would reshape our understanding of biology, evolution, and our place in the cosmos. Moreover, the philosophical and cultural impact would be immense. It would challenge long-held beliefs, inspire new scientific fields, and perhaps even unify humanity with a broader cosmic perspective. If life exists elsewhere, might intelligence also exist? Could there be civilizations far older and more advanced than ours? These questions drive scientists, dreamers, and explorers alike. Though we may be far from definitive answers, every new discovery brings us closer. As we peer deeper into the universe, we are not only searching for other worlds, we are also searching for ourselves. Possibility. What is the multiverse like? In relation to the vastness of the observable universe, let me tell you, the possibilities are endless. The concept of the multiverse, also known as the many worlds interpretation, is a theoretical idea in physics and philosophy that suggests the existence of multiple parallel universes or dimensions beyond our own. Quantum physics, which studies how tiny particles like atoms and subatomic particles behave, is the primary field in which the multiverse is discussed. A quantum system's collapse into a single state can be caused by observation, according to some interpretations of quantum physics. However, in the many worlds interpretation, the act of observation simply causes the system to split into multiple states, each representing a different outcome. It is important to note that the idea of the multiverse remains highly speculative and is not yet supported by conclusive evidence. It is therefore difficult to state with certainty whether it is a valid concept or not. While some scientists and philosophers are skeptical of its validity, others find the concept of the multiverse intriguing and potentially helpful in explaining certain phenomena. Given that we do not know what lies outside our universe, the possibility of the existence of a multiverse remains as valid as the famous Schrödinger's cat thought experiment or the nature of darkness. It is a concept that arouses fascination and reflection but requires more research and evidence to be confirmed. Does the phenomenon known as dark flow exist? The question is complex and raises an intriguing issue. Dark flow came about in 2008 as a possible explanation for the observation that some galaxy clusters appear to move faster than expected based on the distribution of matter in the universe. The concept of dark flow suggests that these galaxy clusters may be influenced by some form of dark matter or dark energy that pulls them in a specific direction. However, the scientific community as a whole has not yet accepted the existence of dark flow, which remains contentious. Dark flow may be real, according to some studies, and it could be brought on by the universe's massive structure that attracts galaxy clusters. However, other studies have failed to confirm the existence of dark flow and have proposed that the observed motion of galaxy clusters could be the result of other factors, such as systematic errors in the detected ones. Even though other studies suggest that it might exist, we cannot say with certainty that it exists outside of the universe that can be observed. To gain a deeper comprehension of this fascinating phenomenon, additional research and evidence are required. What do you think? Please inform us via the comment section. Remember to like and subscribe, and see you in the next video. One of the greatest mysteries in cosmology is the nature of dark matter and dark energy. Together, they make up about 95% of the universe, with dark matter accounting for approximately 27% and dark energy making up the remaining 68%. We have not yet been able to directly detect either of these enigmatic components, despite the fact that they have a huge impact on the structure and development of the universe. We have a bright future ahead of us in our understanding of the universe, and each new discovery opens up new questions. The universe, with all its vastness and complexity, is a testament to the wonders of scientific exploration. The quest to understand the cosmos will likely continue to shape human history for generations to come, whether it's deciphering the mysteries of dark matter, finding evidence of alien life, or studying space itself. As we peer deeper into the cosmos with more advanced telescopes and instruments, our understanding continues to evolve. Projects like the James Webb Space Telescope, the Large Hadron Collider, and upcoming space observatories are expanding the frontiers of what we know, and challenging what we thought was certain. Consider gravitational waves, once theoretical, now observable. Their detection opened a new window into the universe, allowing us to hear the ripples caused by colliding black holes and neutron stars. What other invisible forces might we uncover as our tools improve? In much the same way, the search for extraterrestrial life, once confined to science fiction, has become a serious scientific endeavor. The discovery of extremophiles, organisms that thrive in conditions previously thought uninhabitable, has reshaped our criteria for life. Mars, Europa, Enceladus, and exoplanets in the habitable zones of distant stars are now key targets in the hunt for biosignatures. The vastness of the universe reminds us how much remains unexplored. There could be civilizations out there, separated by unimaginable distances and perhaps even different dimensions. If the multiverse theory holds, then perhaps somewhere out there is a version of you, living a different life, shaped by different choices. Each new question begets another. What is the ultimate fate of the universe? Will it continue expanding forever, eventually tearing itself apart in a big rip? Will it collapse back in a big crunch? Or will it simply fade into a cold, dark stillness? These questions remind us of something essential. Science is not just a collection of facts, it is a journey. A pursuit of understanding that never truly ends. The universe doesn't reveal its secrets all at once. It invites us to wonder, to question, to explore. So as we move forward, keep your curiosity alive. Stay fascinated. Because the deeper we look into the cosmos, the more clearly we see ourselves, not just as individuals, but as part of something much greater. Thank you for joining us on this journey. Remember to like, comment your thoughts, and subscribe for more deep dives into the mysteries of the universe. Until next time, keep looking up.